In this video, we will review what vertex form is for a quadratic equation and how to find the vertex when the quadratic equation is written in vertex form. You can see on the upper right of the page, I've written the general form for the vertex form. It's a times the quantity x minus h squared plus k. And the vertex is the point hk, where h is the x value and k is the y value. So let's start off. I'll write a couple of equations in vertex form, and we'll go ahead and pick out the vertex from them. So let's say we had g of x equals 2 times x plus 2 squared minus 3. If I wanted to know what the vertex was, I would look at this spot to figure out my h or my x value, and I'd look at what's being added or subtracted to figure out k. So in reality, the vertex for this function, g of x, would be at -2, -3. Now you're probably noticing something here, especially when you're talking about the x value being -2. Notice how the sign is the opposite of the sign you see in the original function. That's because in the generalized function up above, you have a negative sign for h. Let's try another one. Let's say g of x was equal to -3 times x minus 4 squared minus 3. The vertex of this function would be at 4, -3. Again, the value for y matches the k, and the value for x is essentially h, and it's the opposite sign of what you see in the generalized form. One more to make sure you got it. Say g of x is 14 times x minus 12 squared. Actually, let's make it plus 5. The vertex of this function, g of x, would be at -12, 5. -12, 5. Okay, now let's try solving for the vertex form, and you do this by completing the square. So in this function, f of x squared plus 10x minus 13, we want to write this in vertex form by completing the square. First step for completing the square is to divide the b by 2 and get that magic number that allows you to write down the perfect square. In this case, you're going to have x plus 5 squared. We have a minus 13. And then we need to make that adjustment that occurs because the perfect square is not quite equal to the first part of the original equation. It's a little bit different. In fact, what happened was we ended up adding a 25, and you get that by squaring the 5. That's the same thing as taking b divided by 2, that gives you 5, and then when you square it, that gives you the adjustment piece. So we need to subtract 25. When you do that, the final vertex form would be x plus 5 squared minus 38. And the vertex of this function would be x is -5, and k is, or the y value is -38. Now let's try a more challenging completing the square problem below, or vertex form, I should say. So the trick on this is you have to factor out the a value. That's right here. So if this was an equation, we would have, and if we were trying to figure this thing out by solving for 0, we normally would just divide everything by 2, and we'd be able to complete the square, and we'd just keep going. But when When we need to write it in vertex form, it's a little bit different. We have to factor out the 2 because it doesn't go away. It's not an equation solving for 0. It's just the entire function. So in order to factor out a 2 from each term, we have to divide everything by 2 to get what's left over. So essentially, we're pulling out a 2. You'd have an x squared minus 4x plus 3 over 2 left over. You could write that as 1.5. That'd be perfectly fine. And notice, if I were to take this 2 and redistribute it to each term, you'd get back the original. That means we pulled out the 2 correctly. We factored out that 2 correctly. Now we're going to go ahead and complete the square with everything on the inside. So we're going to divide -4 by 2 to get the perfect square piece. So we're going to have x minus 2 squared. This is all inside the big parentheses. We got a plus 3 over 2. Not going to forget about that 2 on the outside. It's still there. It's a factor. It's actually a stretch by 2. And then we need to account for the adjustment piece. That is, we have to make an adjustment because the perfect square we created actually ended up adding 4. How did I get that? Well, I squared this thing. I squared b over 2. When you square that, you get 4. So, because this is a plus 4, we have to subtract 4 to make that adjustment. So everything's still in balance. And we're going to go ahead and combine like terms. We'll combine -4 and 3/2. When you do that, you're going to get 2 times x minus 2 squared minus 2.5. And the very last step to having this written in vertex form is we now have to redistribute the 2 to both terms. So you'd end up with 2 times x minus, the quantity x minus 2 squared minus 5. And this g of x is now in vertex form. The vertex will be 2, 5, -5, excuse me. 2, -5.